My name is Michael Baikov. I work at Zuru Capital. We use Haskell for lots of different things. In some cases, we do care about latency. So means we have incoming event, and you have very limited time to react to that event. So I'm going to talk about what latency is, how do we measure it, and that kind of stuff. So here I have a simple socket server and client taken from Haskell wiki. So nothing unusual. Create socket, connect to it, listen for connections in main loop. Once we have incoming client, we send them one single dot. That's helper function to display some stuff. Client gets started from the same binary, connects to server, sends one more dot, and replies. If you try to profile it usual GHC -prof, it will show that like 50% of the times is taken by this function, 50% by this function, but you won't really get any useful information from it. So to measure reaction time, we can use time library, take one timestamp before we connect to server and one timestamp after. And after that's done, we print the duration in microseconds. So this program will start the server in one thread and sequentially execute 10 clients. Whoops. Oops. So it looks like it takes about 40 microseconds between when we send and when we get a response. Yeah, I'm strictly binding for dot here and in the server just to make sure that everything is evaluated. No? Okay. So that's this example. So how can we look into what's going on here? GHC provides that's well, I'm sending 10 requests, and those response times of every request. I will get to it. Okay. At the moment, there is no garbage collection. Because it's not. So GHC provides a backend framework called event log, and inside the debug trace module, it provides trace marker IO and trace event IO. It takes arbitrary string as a parameter and will dump them inside the event log file. You can read with either thread scope or with GHC events. So you compile it with using an event log parameter. enables, and GHC RTS parameter takes L. It's no. So LA will dump all the things. So if we do it 10 times, yeah, it's relatively cheap. As you see, there is no differences in latency. So your GHC event takes a bunch of parameters. Show is one of them. How exactly stuff gets executed? So in operating system you have a concept of threads. Operating system threads are kind of expensive, and if you create like 10,000 of them, it will be unpleasant experience. So in Haskell, the idea is you can have cheaper threads. GHC implements its own model and distributes them across OS threads, and basically you have these capabilities. You specify how much you need using this n parameter. So, and in GHC event log, so first number is a microsecond, nanosecond from the start of the program. Next, capability number, and things it's doing. For example, this here, it's doing garbage collection. And if we scroll lower, there is this markers we placed, information about creating threads, migrating threads, yielding, and so on. So in addition to your own threads you create using fork.io, GHC creates a few of its own threads in threaded runtime. So one of it is main thread. It's usually thread label 1. IO manager threads, one on every capability. They monitor for external events. IO manager is implemented in Haskell and it's relatively readable. You can check GHC sources. And one more thread, timer manager. So there is a paper by Simon Marlowe. He describes how threaded model is implemented. Capability is so okay. Capability is a special marker that gets transferred between underlying OS threads, and you specify how many of those capabilities you have, and that allows you to run exactly this many, to use this many OS threads at the same time. Haskell GHC can create more than available the number of capability you specified OS threads, because well, in some cases you use blocking IO, so runtime must stop, but you still want for your Haskell program to run. There is this concept of bound threads. So you create your Haskell thread, use some kind of foreign function interface, and with bound threads you make sure that this specific Haskell thread will always run on that specific OS thread. That is if you do in OpenGL and stuff, is thread local stuff. So think of capability as a special marker that gets migrated between OS threads and allows to run stuff. Okay. So now we have those threads. It's doing something. We can see what exactly it's doing. We can make it a bit more interesting. Yeah. Mm. So it's not very interesting to measure latency in application that does nothing other than sending and replying messages. So I create this waste time thread that does nothing but yield. So if we have 20 of them, makes no difference. If we add a bit more, so we're starting to see the difference, and there is some requests are taking much longer than other requests. This one, for example, that's when it's doing garbage collection. There is not much can be done about garbage collection latency. So let's create even more threads. No. Yeah, so it's 3 milliseconds.
Largest number of capabilities.
I think it was something like 8. The problem is we don't have well, we have server with whole bunch of different cores, but inside the trader process we run, there is it's mostly sequential. There are several loops that run in parallel, so adding more capabilities doesn't add any benefits. So if you create a thread, it will run on one capability, it will migrate between them. But in order to actually use like 20 capabilities, you need to break down your problem into 20 different threads, and that's difficult. Okay, so we have this 3 millisecond latency. What can we do about it? So by default, this nice slide, GHC creates those nice thread objects. It every capability have its own run queue. GHC runs every thread from that run queue for some time. If if thread's yielding, it gets removed from the front of the queue and added to the end of the queue. If threads is actually doing something, a scheduler will get control in case of thread asks for garbage collection, to allocate more memory, and by default, GHC will try to give control back to this thread if it's running less than 20 milliseconds. That's mostly to ensure cache. That's mostly to ensure that data threads work with stay more in cache. So every 20 microseconds it will be pushed to the end. Every time GHC tries to migrate threads, it will look for empty capabilities. So for example, here I'm not specifying anything about migrations, but if we look at show at event log, it's migrating threads between different capabilities. That's kind of nice. You can specify GHC which capabilities to use using this fork on call. So here, if I pin all the time wasters on capability number 2 and put server on capability number 1. Oops. Yeah, so instead of 3 milliseconds, we are down to 100 something microseconds, except for this guy. The problem with this guy is have one more fork on. And 700 is garbage collection. So using this fork on method, it's possible to achieve a low latency even when your main application does a whole bunch of stuff. The tricky bit is you have to pin your threads manually. It's not very fun. So I made a change to GHC to this scheduler. So thread state object contains a bunch of different fields: register, point to stack, thread ID, some other stuff. I added 2 fields specifying minimum and maximum capability number to run this on. And when GHC tries to migrate, it does a bunch of checks. For example, you don't want to migrate thread that is pinned to specific OS thread unless capability migrating to is running on that OS thread. So I added one more check that confirms that you can migrate to that capability, and you can achieve similar effects, but without managing your threads manually. Interface looks something like it. No, for on time. So something like this. So thread server will be migrating between capabilities 2, 3, and 4. And currently I'm too lazy to actually publish this. There is still some problem with test framework, but in our tasks it works. Maybe. This means GHC can migrate this thread between capabilities 2, 3, and 4. Yeah, 2 to 4. I had version that used bit masks, but Simon Marlowe said it's not going to work very well if you have more than 64 capabilities. It kind of would, just well, in application itself there is this tape, so that name feed parser. So there is this data type, and there is function. So you can specify the actual interface for us. Actual interface looks like this. You specify thread name, and there is exactly one function where you still manually distribute, but it's exactly in one file. And we run it with the same number of capability all the time anyway. $7.10? Yeah. There is some latency related problem starting from 7.10.2, and when I never bothered enough to actually look into it. Any? No, it's a small C file, a small C patch. Well, there is differential with the bitmask version, and it accidentally quadratic complexity under some condition.
No, seriously, my knowledge, you are, for example, then it's not that hard because more average.
No, it's possible. In our case, we have limited number of threads. We trying to control how much garbage is collected. So there is, for example, a special function that takes any object and tells if it was fully evaluated or not. So
unless you are using cloud,
no.
we change the run. Is it GC?
GHC at most in our case takes 200-300 microseconds. It's not a big problem. And Trader itself uses about 200 megabytes. We don't. It's whenever GHC decides to. No, much more often. No, it's milliseconds.
Because GC studying about graph, so you see GC communicating.
Well, we're not at that point yet, but currently the idea is to split out all the latency sensitive stuff into separate process and synchronize data between them. Plus, depending on type of your data, you might have better luck using compact regions. So the idea is, if you want to get latency, you need to understand your threads. You need to understand how often they run, how much work they do. You can pin them manually. You can implement your own change to scheduler. You can wait until I release it. I don't know. GHC will spawn some of the threads of its own. For example, if you use weak pointers, every garbage collection, GHC will spawn a separate thread that will deal with those weak pointers. If you use GTK, GHC will spawn threads on incoming calls from GTK. A bunch of libraries on Hackage will spawn their own threads, even if name doesn't look anything like that. If you want to find out about those, you compile your program using gflag and use GDB to set a breakpoint on I think it's called like this. So if you have surprising threads in your program, that's how you look for them. If you use Sparks using par, every scheduler run, if capability is empty, GHC will look for existing sparks and will create a thread to evaluate those sparks. Currently, there is no way to pin Spark threads to specific capability, so you need to be careful about that. Again, if you care about latency. Any other questions? Very good. Yeah, it's very good. I mean, the most expensive part that cannot be avoided easily is garbage collection. Garbage collection in our case is about 300 microseconds. It's manageable. Compact regions is what, 8.2. we're still at 710. Any other questions? How many what? Many calls. 6. Well, there is one process that uses 6, one process that uses 3 more, and that's about it. There is some other processes doing analytic stuff, but it's running on a separate server. Well, you need to understand what is going on inside the program. So one of the way is to look at this GHC event log. For example, in some cases you see so for example here we have thread number 3 waking up thread number 6 on capability 1, and thread 3 immediately stops running and wakes up thread 6. In this example everything is good. There might be case when thread on one capability wakes up thread on different capability, but the profiling shows that it takes like half a millisecond to actually wake up this thread. You just need to look at what exactly this capability is doing. It can be in the same log, scroll up, scroll down. Usually it's running something. So again, if you understand what it's running, you will be better at controlling it. Thread scope, yes, but it's not working very well if you have big event log file. Event log is not working very well either, but I also have my own version that that performs streaming processing, but again, I'm never bothered enough to actually publish it. Yes, the problem is there is absolutely no configuration except for taking file as a parameter. I just write my own version every time I need to look at something else. It provides some interesting pictures showing that this capability and this capability are running both at the same time. It provides that information that, so let's see. So it creates this rectangular looking matrix. And 1, 2, 3, 4, and 3, 4. So suppose I have 4 threads. It will look something like this, meaning thread 1 and thread 2 running at the same time more often. Yeah. Well, it's supposed to be symmetrical. So that's the idea how you can visualize interaction between threads. It's just 500 by 500. And the same for capabilities. It's 6 by 6. More questions?